Welcome, my dear friends. Today we are talking about welding machine design. So, here we will design a 400 ampere 60 volt DC welding machine. So, this welding machine is based on resonant converter based design so that we can take very minimum losses across the IGBT or any switch devices. The feature is adjustable required current. So you can adjust whatever the current you required, you can adjust with the help of current set pot. So maximum current is 400 ampere, and if you want to take a less current, you can set with the help of adjustable pot and you can take whatever the current you want. But more than 400 ampere, it will give a fault. That is called overcurrent protection indication or overcurrent protection fault. So here we have given a protection. If the system is drawing more than 400 ampere, its system will go in protection mode. So this full design is IGBT based design, and it is a homemade design by Anil Vishwakarma, and Science Innovative Brain is our YouTube channel. So we will proceed. So this is a three-phase welding machine, 400 ampere, 6 volt DC. So this is the three-phase welding machine we are talking about this. So in this design, we will explain how the power flow from input 3-phase to output 60 volt DC across the welding rod. Which equipment we want to weld it with the help of welding rods. So first of all, whatever the input supply is there, we will rectify with the help of bridge rectifier. So here three-phase bridge rectifier is used. So we have used here DF60LA80, means it is a 60 ampere diode block and 800 volt its peak repetitive voltage, reverse voltage. So this voltage, three-phase voltage will rectify, and after the rectification, current will flow from this R1 and this capacitor bank. You can see here 6 C1, C2, C3, C4, C5, C6, C7, C8. So each capacitor is 450 volt rated, and the Faraday value is 860 microfarad. Okay. So if you take the whole capacitor bank, the value is, so maximum voltage is 450 plus 450. So we have to add it, so it becomes 900 volt DC. So maximum we can charge this capacitor to 900 rated value, but we are charging approximately 565 volt DC with the help of this three phase. So this, if you see here, so total Faraday is 8680 divide by 2 because it is in series, then multiply by 4 times. So total capacitance value we can find out. So after, when the capacitor is charged, means this DC bus is charged, this is negative, this is positive. So when it is charged, it is slowly charged by this resistor. This is called current limiting resistor or surge protection. If we will charge directly, because capacitor will behave as a short circuit in initial case, so your MCB or your power system or your diode can damage. So to avoid this damage, we will charge this capacitor with the help of 120 ohm. This 120 ohm wattage is approximately 200 watt resistor. So as soon as when the capacitor is charged approximately 80%, this R8, R9, R10, R11, 12, 13 and 7 will find the voltage across this capacitor, and then it will generate some voltage across R7. Accordingly, this optocoupler will start working. When the optocoupler is charged, or when the LED inside the optocoupler is on, this optocoupler phototransistor is in on condition. When this is on, what will happen? It will generate a voltage. So voltage is taken from 15 volt. This is control power supply, and this control power supply will go and trigger this Q5 2 and double two transistor. When the transistor is on, this relay will on. When the relay will on, this R1 become bypass. Okay, so this R1 is bypass, and this capacitor is now directly connected with the input of the output, or you can say output of the diode. Directly it will connect, so that we will get higher current when the welding machine we are operating. Okay, so I think this funda you will understand. And for 15 volt, we will take a transformer which having input voltage 400 VAC and output voltage is 15 volt AC. So this is a two-phase transformer we are using here, because I not use here any neutral. You can use a neutral also, and you can use a 230 volt by 15 volt transformer to design this supply, but in that case we required one extra neutral line. So after 15 volt, we will rectify this with the help of bridge rectifier, and then filter out with the help of 1000 microfarad capacitor. Voltage is minimum 50 volt. You can take this capacitor value, and then 0.1 microfarad for the any surge or any noise protection. Then after that we will put one regulator LM7815CT. This voltage regulator will provide always constant 15 volt at output, and when the output is come, this LED will indicate we have a control power supply is turn on, or if it is failed or anything problem is there, it will not glow and it will show control power supply is not on. So with the help of this system, we will generate a 15 volt DC plus here minus here for our control supply, like this relay we are operating for to operate this relay. After that, what will happen? We will trigger this IGBTs. This 4 IGBT is there. You can say this is the half bridge one single module IGBT. So Q1, Q2 you can find in a single module. Q3, Q4 you can find in a single module. This IGBT value is CM100DY-24NF. So this is a 100 ampere 1.2k volt IGBT. This is the half bridge IGBT in a single module. So we require two IGBT here, one for this section, one for this section, so that we can make a full bridge inverter. And how we will trigger this? This trigger gate pulses will come with the its control circuitry that we'll discuss later. So after that, when the switching is happening here and output is generating, so here the output will get at this point and this point. So here we have connected one capacitor. Approximately this will come as a 0.4 microfarad capacitor in series with the transformer. So this T1 is the our main welding machine transformer. So we have connected this transformer in series with the capacitor. Then one more current sense transformer is connected, then output is connected to this point. Okay, so that this transformer, whenever this transformer will operate, so when whatever the current is there, that is sensed by this transformer, current transformer. Okay, whenever the load current is flowing or whenever the initial current will flow, all will sense by this transformer, and it will give the command to the control circuitry that we will discuss. So this circuitry is called a resonance converter based circuitry. So this is called tank circuitry. So here L and C. So if you see here, this is the capacitor, and a small leakage reactance of this transformer will put in series so that we can make a full tank circuit. I not shown here a leakage reactance of the transformer. We have to practically find out, and we have to describe it here in series with. So now after the transformer, and this transformer is having 48 turns in the primary and 5 turns in the secondary, so that we can generate a 60 volt DC here. After this output, we have connected a diode. This diode is dual. You can say 7 8 is in one piece, 9 10 is in one piece, 11 12 is in one piece, and 13 like that. This diodes are in, we have connected to increase the current rating of the system, so the diode will not damage when we are drawing a 400 ampere from the output. So this diode will rectify from here, and this is the output. So half wave rectification will happen here. This is just for the protection. Okay, and this R and C is the protection for the diode. And after that, if you see here, same also we have connected a protection diode, protection circuitry for this diode also, R and C. After that, if you see here, was 6 microhenry inductor I have connected in series with the return path or negative side. Why? Whenever we will start doing the welding, one surge current will flow because of the short circuit. So that surge is limited by this, initial surge is limited by this inductor. That's why we kept this inductor to avoid the output surge. Otherwise it will cross the secondary current also, and it will give the false trigger, and you cannot operate the machine each and every time. Okay, so I hope you understand this circuitry. And here, when the CT will sense the current, it will generate some voltage across this 100 ohm resistor, and then we have rectified this output and make a DC. After this, we will go for second phase. I think you people are understand all this circuitry. Now we'll go for second page. So this page will describe the PWM generation, IGBT gate drive, and overcurrent set. So this inverter or this welding machine is designed based on SG3525 PWM IC. If you see here, the IC is PWM IC is here. Okay, so same 15 volt, whatever we have generated from here, same 50 volt we are utilizing for the our control circuitry. So same 15 volt we have given to this IC. This is return path negative, and then in this PWM, if you see here, the pin number 8 is, this is soft start circuitry capacitor. So we have to put 0.1 microfarad, so the system will start softly. It should not start hardly or fastly it will not turn on the system. So here if you see this circuitry, you can understand, or we will describe in any other further lecture if you require to understand how the PWM is generated by SG3525. So this whole circuitry is designed approximately 20 kilohertz switching frequency. So for the switch, taking the 20 kilohertz switching frequency, this R20 and C18 is responsible. This R19 is the dead time control. If you want to understand how the inverter is working or what is the dead time for the PWM, you can refer my previous video lectures. I will put the link in the I button. You can find from there also and in the description also. So this is the feedback voltage, FB. Whenever the output will generate, we will take a feedback from this section. So FB we will take as a current feedback. So here if you see, this feedback is going to the IC, and this is the common ground. So when the feedback is coming to pin number 1, we have set here control, current set pot. So here the current set pot is there. With the help of this current set pot, you can adjust the current from 0 to 400 maximum current. So here with the help of this pot, you can adjust it, the current whatever you require to set for the machine. So when the, if you set here, if I will give 4 volt, I made the circuitry so that maximum voltage will come 4. So when 4 volt is there, you will get a 400 ampere, and the feedback, whenever the feedback is crossing more than 4 volt, system will go in protection mode. System will off it or regulate it. It will not off it, it will regulate it. But whenever the feedback is crossing more than 4.2 volt, here also this pot is called overcurrent set pot. This current we have to always set more than our current requirement. Means our machine is rated for 400 ampere, so I have to set it little bit higher. Let them 5 ampere extra, so that whenever the system is crossing, my system will get in protection mode and it will not damage any IC or any other component. So this comparator is used to set the overcurrent limit. So whenever the current will come over current, so here you will get a LED indication. Whenever the current is crossing more than whatever the set value is there, 400 ampere, approximately you can say 405 ampere, then this, now it is set for 420 ampere, we will reduce to 405 ampere. So whenever the system is crossing 405 ampere, this current will this LED will glow it, and same time it will generate a command for here for this transistor. So this transistor is on, and this will discharge this capacitor, so output PWM will off it. So PWM generation is across the pin number 14 and 11. So here we used one gate triggered transformer. Gate triggered transformer we used here. So whenever his pulse is generating from 14 and 11, so let us know 14 is high, then 11 is low. Whenever the 11 is high, 14 is low. This is complementary pulse will generate here. So when it is going to transformer, transformer will generate another 4 pulses. You can see here one dot is here, so similar dot is here. Here the dot direction is opposite. So this, if you see here, this will go for the one module higher side, and another module lower side. This will go another one module lower side and one module higher side, so that we can operate the system in crossway. So if you see here, I01, I02 and I078 will connect here. So same point, so 1, 2 and 7, 8 will connect this point. So these two will turn on at a time and these two will turn on at a time. So system is operating in cross. So this IGBT 1 Q1 and Q4 will on at a time, then Q3 and Q2 will on at a time, and in between the turning on some dead time control is there, approximately 1.3 to 5 microsecond dead time. So here if you see the dot, when the pulse will come here, so this will come high and this become high, and this, in this condition, this become low, this become as a high, because it is a winding reverse. So this winding is another direction, this winding in another direction, so that we'll get one side, this side is positive, and in this case this side is positive. So this two will on, this two will off. And this circuitry, gate trigger circuitry, if you see, so here let us assume I will explain first only one portion. So whenever the high is come here, so it will go here command, and through this path it will go to this, and this Q1 will on it. Okay, so when the Q1 is on, it will store some charges across the gate, so it will not allow to off the system. Okay, so and the same time, if this is pulse is reverse and this is fired, means this is fired, this is not get it off, and this is fired. So what will happen, the shoot through will happen across this, and this IGBT will go damage. So to avoid this, whenever the off when the this is going to on, what will happen, the charge will come from here same path, and this, through this transistor it will discharge it. So whatever the extra charge is there across the gate, it will follow the this path. So charging is happening like this, and discharging of the charge will happening like this path. Okay, this loop like that. For the all, it is happening in same manner. So this total is the PWM generation, gate drive and overcurrent set circuitry. Here I will show the DC bus voltage and current waveform at 25 ampere. If the system, I explained previously, whatever the capacitor bank is there, if you take the single capacitor bank and you will take the current approximately 52 ampere, means you, if the system is drawing 52 ampere, but our system will not not draw 52 ampere, because it is a 400 ampere, approximately 24 kilowatt system. So in this case it will come as approximately 30 or 40 kilowatt system, three-phase system. So we are not going for that much. So in this condition, if the system is drawing 52 ampere, if you see the voltage waveform and current waveform is this across this bus bar when the system is operating full load condition or overload condition. Okay, so if you see here, the 200 volt one, so 200, 200, 400, this is approximately 565 volt line, this line. So this is voltage waveform, and if you see whatever the current is drawing, they here for the explanation purpose I taken one register and taking the output. So in this condition, current is approximately, if you see 50 ampere one block to 50, and if you see here it is coming approximately 51.7 ampere in this section. Okay, now if I will show here, so in this, so it will show the graph, uh, ripple across the 51 ampere. So if you see in the same condition, I put the multimeter or scope in AC condition. If you see, the voltage ripple is approximately 20 volt peak, and peak to peak approximately 40 volt. So this is 20 and the current is 50. Same current is flowing in this condition. Okay, now I will show for the actual operation current. So if the system is rated for 24 kilowatt, so system current is approximately 34 ampere. So in this condition 34 ampere, so voltage is approximately, if you see here, voltage is 526 volt and current is approximately 35 ampere. So green is current and red is your voltage of the DC bus. So this is the total simulation of the three-phase welding machine. So in this manner, we can make a three-phase welding machine at home by using this all circuitry and all components. So here I defined all the component. If you required any other component, whatever, you are not able to find it here and it is costly, but I have optimized to get a very minimum and optimum price all the components. So I will give a biome for the this machine, and the full circuit diagram you can find and download it from my description box. So I hope you understand this resonance converter based three-phase welding machine, which is rated for 400 ampere and 60 volt output current, output voltage. So if you like this channel, please subscribe it, and I request to all and new subscriber, please watch it and subscribe it. Don't forget for subscription and press the bell button so that you can find the this type of circuitry and designs in the future video lecture whenever you are taking the notification. Okay, thank you. Bye bye.